Have you ever been to the beach and noticed how the ocean moves in and out, sometimes covering more of the shore and other times retreating far back? These rising and falling water levels are called tides, and they're a fascinating part of how our oceans work. But why does the ocean have tides, and what causes this regular pattern? Today, let's dive into the science behind tides and explore what makes them happen. To understand tides, we need to know about two major forces, gravity and Earth's rotation. The primary force that creates tides is the gravitational pull of the moon. Even though the moon is much smaller than the Earth, its gravity still affects the water in our oceans. When the moon's gravity pulls on the Earth, it causes the water closest to the moon to bulge out slightly in its direction. This bulge creates what we see as high tide. But that's only half the story. There's actually a second high tide on the opposite side of the Earth, farthest from the moon. This second bulge happens because of something called inertia. In simple terms, inertia is the tendency of objects to resist changes in motion. As the moon pulls on the water closest to it, the water on the opposite side of Earth is left behind, creating another bulge. So, we end up with two high tides, one on the side facing the moon and another on the opposite side. Between these two high tides, we also get low tides. These occur in areas where the water is stretched away from as it flows toward the two high tide bulges. So, as Earth rotates, any point along the coast will experience two high tides and two low tides every day. But it's not just the moon that affects the tides, the sun's gravity also plays a role. Even though the sun is much farther from Earth than the moon, it's so massive that its gravitational pull still impacts our tides. When the sun, moon, and Earth line up in a straight line, the gravitational forces of the sun and moon combine to create spring tides, which are higher and lower than normal. This alignment happens during full moons and new moons, leading to extra high and extra low tides. In contrast, when the sun and moon form a right angle with Earth, their gravitational forces partially cancel each other out. This creates neap tides, which are less extreme, with smaller high and low tides. Neap tides occur during the first and third quarters of the moon phase, and they're much milder than spring tides. But tides aren't just influenced by the moon and the sun. Other factors, like the shape of the coastline, water depth, and even weather conditions, can affect local tides. For example, in narrow bays or shallow areas, the water can rise and fall more dramatically than along open coastlines. Some places experience only one high and one low tide per day, while others have more complex patterns due to unique geographic features. Here's a fun fact: tides aren't just limited to the ocean. Lakes, rivers, and even the solid ground experience tiny tidal movements caused by the gravitational pull of the moon and sun. These movements are so small that we don't notice them, but they're happening all around us. And on other planets, moons like Jupiter's Europa experience incredibly strong tidal forces due to the massive pull from their planet, causing the entire surface to flex and shift. To sum it up, the ocean has tides because of the gravitational pull of the moon and, to a lesser extent, the sun. The moon creates two high tide bulges on opposite sides of Earth, and as Earth rotates, coastal areas experience these bulges as high and low tides. Other factors, like the coastline and weather, can also influence how we experience tides. So, the next time you see the ocean creeping up the shore or pulling back to reveal more sand, you'll know there's a cosmic dance happening between the Earth, the moon, and the sun. If you enjoyed learning about tides, don't forget to subscribe for more science explainers. And tell us in the comments, have you ever noticed how the ocean changes throughout the day?